Hi, I'm Thomas Aslam Ballas, the lead developer behind Sirius, a concealed broadcasting agent. Over the next few minutes, I'll explain in detail what Sirius accomplishes and the mechanisms involved. But in order to truly understand Sirius, you need to understand why I built it. What need existed in the world to bring about its creation? A need that starts with 47. That's 47 Facebook friends, 47 Twitter followers, 47 bloggers. What these individuals shared in common was that in 2013, each of them said something. They said something that their governments found so offensive, so inherently terrifying, that the only suitable course of action was to put these individuals to death. The need for Sirius comes from a further 165. Depending on your perspective, these may be the lucky few. These individuals weren't put to death for what they said, but instead now spend their nights in prison cells, their days toiling in labor camps. So let's put ourselves in their perspectives. Let's say that we had a message. The government is now prosecuting political activists as terrorists. And we wanted to get that message out to the world. So we packaged it up and we sent it down the wires. When it hit our ISP, the network censors ripped our message open, saw what was contained within, and decided that there was absolutely no way that this should ever be allowed to the public. Our message was dropped, we were investigated, arrested, and if we're particularly unlucky, executed. So that didn't work. The next solution, if you know information security then, is to take that same message and to encrypt it using some sort of strong cipher. Then you'll take that encrypted string and you'll send that out to the people that you want to read your message. One of two things happens when it hits your network sensors. One, if your government is strong enough, they rip it back open. They decrypt your message, and you're just as bad off as you were in the first case. The second option, though, and this will happen regardless, is that you've now created a homing beacon. You've painted yourself as a suspicious character, somebody who's trying to evade state scrutiny. And in some localities, just the very act of encryption is in and of itself illegal. You'll be arrested for that. So we propose a different solution. We take your message, we encrypt it to maintain the security, but then instead of sending that encrypted string, we hide it. We send it invisibly in something inconspicuous. Maybe a photo that I took on a weekend trip. So we take that photo, we send that out down the wire to our friends. When it hits the sensors, they rip it apart and see not encrypted text, not a revolutionary message, but just a weekend photo that I'm sending off to some close friends of my own. It gets through the sensors without issue, without further scrutiny. So how did I do that? How did I take my message and make it invisible? Well, for a while now there's been this technology, this technique known as steganography. That's the act of hiding information within something such that it arouses no suspicion. And for those of you who aren't digital photography enthusiasts, you may not quite know how digital images work. On your left, you'll see what you normally see, a pixel, a little square of color. But on your right is the data that your computer sees. What we can do is we can change that data, just a tiny amount, so the color change is imperceptible. But to a computer, it's a fundamentally different thing. And now we can use these pixels as containers for individual bits collected together, bytes, and across a photo, very long amounts of information. It remains absolutely imperceptible to humans because of the 8 million or so color combinations available. We chose the one right next to it. So, we take a couple of these pixels. Here we have 8. They're all perfect red. And we change a few of them just ever so slightly. What I'm going to assume is an imperceptible change to you. So the top row is all zeros, but on the second row, the second and final reds have been shifted by 1. To a computer, we can read this back, and that 0, 1 string that you see here is the Unicode letter A. This could very well be the start of our message. So Sirius enables this. It allows you to hide messages in photos. But it goes one step further. Instead of simply sending that photo from point A to point B, a very obvious metadata connection, we take that photo and we send it to a series of relays. It could be Imager, Facebook, TwitPic, and many others. What we're doing here is what I like to think of as the Cold War dead drop. We're taking a message, hiding it in a Coke can, and tossing it off a highway. Hours later, our partner comes and picks it up and pulls the message out. But to anybody who doesn't know precisely what's in that Coke can, it just looks like I'm littering and my friend is cleaning up. What we do here is we use these websites as inadvertent cloud storage. We exploit the trust between the governments that let these websites in and the private organizations that give them access to their data. As long as neither party knows that there's anything abnormal about this photo, it'll sit perfectly hidden in plain sight. So, let's see what that looks like to a user. Here we're going to watch as our individual draws up a new message. Prior to this entire process, we can say that they registered an account with Imager as their receptacle for these photos. So what they're going to do is they're going to type out their message. The government is now prosecuting political activists as terrorists. When they finish typing out what they want the world to see, they're going to hit the send button. This declares them finished with their message and brings the next step. What we're seeing now is the camera previewer. In this moment, in real time, they're going to take the photo that's going to hide their message. Quick dialog box is going to pop up saying that the system is about to perform a number of very heavy calculations. What's going on at this time is that their message is being compressed, encrypted using military-grade AES encryption, and then injected into the message in a very secure fashion. All of that before being autonomously uploaded to the website that they had previously registered. And now we can see that they're completed. Our user is now done. What happened in the background is that that photo was uploaded to Imager where it now sits. And being a rather inconspicuous and downright boring photograph, it's probably going to get only one view over its entire lifetime. But that one view is our server, who's going to pull for this image, and when it gets it, it's going to run the entire process in reverse to pull out that text. When it has it, it's going to post it to Twitter anonymous of the individual that originally put it forward. So let's look at the whole picture. We have a user and their message. Sirius encrypts it and then hides it within a photograph. That photo is then sent off to Imager, where it sits for some period of time until our server comes and asks for it. The server runs the entire process in reverse, first extracting the encrypted data, decrypting it, and then taking that plain text and posting it anonymously to Twitter in a multi-hop, multi-step process that makes it almost impossible for anybody to discern precisely where this message came from. I'd like to say that I was able to throw that seemingly simple process together in a weekend and enable free speech, but a lot actually went into this. It took 8 months, and I had to overcome a series of complications brought forth by a number of things, including our mobile interface. I'm sure this will come as no surprise to most, but mobile phones have a lot less processing power than your average desktop computer. This meant that everything I wrote in code had to be hyper efficient. Further, the Android operating system, like most, combats developers, trying to restrict what they can do to prevent malicious activity. This meant that I often found myself at odds with the operating system that I was developing for. Next, steganography is a largely ignored field in information security. This meant that when I needed information, I had to dig deeper and often got less than if I had gone the simple cryptographic route. What's more is that ends up resulting in far fewer code implementations available online, which meant that I had fewer to dig into and often had to write things on my own. Next, the relays pose their own issue. You may not be aware, but Facebook will compress your images when you upload them to save space on their servers. In most cases, this is fine, but it destroys the message that we're trying to embed. Therefore, we had to select our relays under the property that they would not compress images. Further, in order to enable future extensibility, we had to design it for a minimum set of requirements. That was that a user could upload an image, and that the server could pull based upon a username to download images later. Finally, and most importantly, the entire system had to be secure. This meant that no data could be leaked, that nothing could be made public. So a lot of code had to be written by hand. This further added to a timeline that spanned 8 months, hundreds of cups of coffee, and thousands of hours. It was quite the undertaking, but I feel like I did it for a good cause. for the countries that you see in red and black here. Places where opening your mouth and putting forward an idea can very well mean your life, whether that's ended just a few short days after hitting enter or following 60 years in a prison cell. Countries like Saudi Arabia that recently enacted a law that allows them to treat any form of political activism as acts of terrorism against the state. And countries like Turkey, who shortly after Saudi Arabia installed a bureaucratic office to determine what is offensive speech. And not only do that, but also disrupt the country's access to those websites while further investigating the people who put forward that information. We watched this no time later that they blocked access to both YouTube and Twitter following a political scandal for several weeks. And when Twitter was finally allowed back into the nation, they made demands that Twitter give up the identities of the individuals who put forward that information. What I'm getting at here is that this is a large issue. It's always been an issue, but it is now a growing epidemic in the digital world, the censorship of free speech. And while I'll never claim that Sirius is the end-all solution, the silver bullet to what is an internal problem, I will claim that Sirius has the capability to do a lot of good, to protect individuals from those who wish to bring them harm for simply putting forth an idea. Thank you for listening to my presentation on Sirius. If you're interested in more information, please get in contact with me, Thomas Ballas. Thank you.